All right, let's take a look at the limiting reactant problem. And from now on, you should assume that all stoichiometry problems are limiting reactant unless explicitly told otherwise. And you would be told that if they say, in this case, ammonium chloride reacts with an excess of calcium hydroxide, but they didn't. So we're going to assume that this is a limiting reactant problem. I always want to look ahead in the problem, and I should also acknowledge that there are different ways to do limiting reactant problems, and your teacher may teach you differently. But I'm going to look ahead to part B and notice that they ask us something about ammonia. So I'm going to base my calculations on part A for the limiting reagent on the amount of ammonia produced. It should also be noted that you can do it for calcium chloride and you'll get the same answer. You'll just have to do a slightly more difficult, well, maybe not necessarily difficult, but an additional calculation. So let's take a look at the limiting reactant. And the limiting reagent is going to determine the amount of product that's formed. It runs out before the excess reagent, so it's completely consumed, and then the reaction will stop. So we're going to start with both reagents, and my strategy is going to be to convert them to moles of product. In this case, I'm going to pick moles of ammonia because question B, or part B, asked me about the amount of ammonia that could be produced. This has been separated into two slides just for clarity, but you can do it in one step. Also, these slashes right here shouldn't be there. They're extraneous. So in the first analysis, we convert to moles of ammonium chloride and calcium hydroxide. You don't need to stop here and calculate them. You can just do a longer string, and we're going to show that here where we convert moles of reagent to moles of product. So I would do this in just one calculation. But again, I'm going to use stoichiometry to determine the moles of ammonia that could be produced. And again, these slashes haven't been canceled and shouldn't be there. So we use the balanced equation to determine moles of ammonia. And what this calculation is telling us is that if all the ammonium chloride reacted, we could produce this amount of ammonia. On the other hand, if all the calcium hydroxide reacted, we could produce this amount of ammonia. This follows that the ammonium chloride is the limiting reagent. We don't have enough ammonium chloride to produce this amount of calcium hydroxide. Now, as a tip, I would cross out this value right here. You're not going to use that in the way I present limiting reactant problems ever again in this problem. So cross it out. It's just going to confuse you going forward. You could also take these values to grams, but whatever produces the fewest moles is also going to produce the fewest grams. But you would, of course, have your answer for part B already. So what is the maximum mass of ammonia that can form? So we're going to convert moles of ammonia to grams of ammonia using the molar mass, of course, to get the answer. So what this calculation is telling us is that around 21 grams is the maximum amount of ammonia that can be produced. There should be three significant figures in this answer because we started with 66 grams. We carried an extra digit here for accuracy, so they should be reported as 21.0 grams. So most people get A and B, no problem. It's part C that tends to be the most difficult. So the mass of the excess reagent that remains is always the mass that we started with minus the mass that was consumed. And we're always given the mass that we started with. In this case, it's 66.0 grams. Remember, you need to identify the excess reagent. It's calcium hydroxide. So keep that in mind. If you use the limiting reagent here, you would get an answer that was suspiciously close to 0. If you get an answer of the mass of the excess reagent left over as 0, that should be an indication that you've done something wrong. I do this problem actually slightly different than the way Taz did it, but I will present Taz's work, then explain to you what I do. This becomes a simple stoichiometry problem to determine the mass of the calcium hydroxide that is used. We know that 1.234 moles of ammonium chloride, or we could also start with the 66 grams of ammonium chloride reacted. It's completely consumed. So we can convert this to grams of calcium hydroxide that must have reacted. So in other words, if I tell you that this many moles or grams of ammonium chloride were consumed, we should be able to access the grams of calcium hydroxide that reactant. And again, notice how I write out the formulas here. It helps me figure out the ratio between the moles using the balanced equation. So here, what this tells me is the amount in grams of calcium hydroxide that reacted. I generally do this by taking the moles of ammonia that were produced. So I would have started this calculation here with the value in moles that we got from part A, from the limiting reactant, and converting it to moles of calcium hydroxide that way. It actually doesn't matter which way you do the problem, except this requires an additional step to calculate the moles of ammonium chloride. So that's why I wouldn't do it this way, but however, either approach will give you the same answer. The answer here should be reported to 3 significant figures, noting that we carried an extra digit here, so 45.6. And then when we calculate the mass of the excess, notice we'll keep 1 decimal point. So our answer should be 10.4. So again, part C is a little tricky. The next tutorial presents the alternative approach to part C that I favor, but either way works. Good luck.